Imagine trying to catch a train in the late 19th century. You arrive at the station, look up at the board, and realize you have no way to know when your train actually leaves. The problem is that every town along the track is operating on its own distinct solar time. In North America alone, the landscape was fractured into more than 144 conflicting local times. A traveler moving east or west had to constantly adjust their watch just to match the specific position of the sun over whatever city they were pulling into. This timetable from the Midland Counties Railway shows the results of that confusion. Without a standardized system, railway schedules became a knot of overlapping arrivals and departures, leading to missed connections and deadly train collisions. For most of human history, this lack of precision wasn't a problem. People worked the fields and tracked their days by the arc of the sun, the shift of the seasons, and the local weather. If you knew the sun had reached its high point, you knew enough to survive. But as mechanical speed outpaced the sun, solar time failed. The mechanical clock emerged as a technological fix for the chaos of industrial progress, eventually becoming the invisible infrastructure of modern society. Long before the railroads, the earliest mechanical clocks appeared in medieval Europe. These were massive, weight-driven machines housed high up in stone towers. If you looked at one of these early devices, you wouldn't find a familiar face. Their sole purpose was to ring bells to wake monks for scheduled prayer. This religious origin is why the word clock itself is related to medieval words for bell. Accuracy improved in 1656 when Christian Huygens built the first pendulum clock. By harnessing a regular swing, his design reduced errors from an hour a day down to under a minute. This accuracy made clocks trustworthy enough to regulate public life. This shared signal allowed thousands of people in a growing city to finally act in unison, providing the coordination needed for organized urban life. This synchronization eventually reached the factory. The Industrial Revolution replaced the weather-dependent rhythms of farm work with rigid mechanical schedules. Inside these factories, human labor was governed by bells. Workers were forced into 12 to 14-hour shifts that were synchronized exactly to the movement of the machinery. By the late 19th century, employers used the physical time recorder to track employee attendance directly for payroll. Wages became tied to the exact minutes spent at a station, making productivity and discipline something that could be measured and priced. Managers could now use these physical records to enforce penalties for tardiness and officially define the length of a regular workday. Because the punch clock recorded every instance of tardiness with mechanical precision, this established the modern idea that being on time proves you are a reliable worker. This strict pacing soon expanded beyond the factory. Driven by the threat of crashes and missed connections, railroads pushed the United States to consolidate into standardized time zones in November 1883. A similar problem existed at sea. Without a dependable way to track time on ships, mariners struggled to calculate their position, resulting in lost vessels and failed voyages. John Harrison's marine chronometer solved this, enabling navigators to compute their longitude with precise accuracy at sea. Reliable navigation meant safer trade routes and predictable travel, linking the global economy tighter than ever. By adopting a single, shared system, humanity effectively unified the distances between cities and oceans into one temporal grid. In the 20th century, quartz technology made reliable timekeeping accessible to everyone. These watches use the vibration of a crystal to maintain a steady rhythm, providing low-maintenance accuracy to billions. The final shift came with the atomic clock. By measuring the frequencies of atoms, scientists reached a level of precision that redefined modern technology. Today, our essential systems, including GPS, internet routing, and global banking networks, depend entirely on this ultra-precise atomic time to function. This level of precision changed how we perceive the day. Instead of following the sun, we began dividing our time into exact units that could be assigned to tasks, compared for efficiency, and sold for a wage. The clock did more than help us organize the day. It turned time from a natural rhythm into a system, and once that happened, our labor, our travel, and our daily habits began to move to its beat.